Hello guys and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class topic, we are still going to talk about linear algebra since we are still talking about mathematics. And my main goal today is to introduce you guys to the concept of projection. So basically, what exactly is a projection in linear algebra? So it's pretty simple to understand. You'll see maybe the concept seems a little bit complicated, but you'll see when you will see what it looks like. You'll understand that is pretty simple. All right, so let's start. So basically, what exactly is projection in linear algebra and all its real-life applications? So basically, in linear algebra, a projection is simply a linear transformation P from a vector space to itself. So we can see it, for example, that is, let's say, for example, the vector space, let's say that the linear projection P will be P2. It will be equal to P. So in other words, whenever P will be applied twice to any value, it will give the same result as if it were applied only once. So it means that it's idempotent. So it leaves its image unchanged. So basically, the projection of a vector space V can be a linear operator. So what exactly is the projection of a vector? So the vector projection is the vector that is produced when one vector is resolved into two component vectors. One is parallel to the second vector and one that is perpendicular to the second vector, the parallel vector on the vector projection. So in other words, basically, you will have two vectors, and what it will look like, basically, it's gonna be one vector will go over the other vector. So it's a bit complicated to see right now because there is no pictures, but in the example part, I'll show you what it looked like, and we are going to talk about the formula behind what a projection is. Finally, what are real-life applications of a projection and why exactly are projections done if it's just one vector on another vector? So its main utilities are mostly in physics, so basically in physics and in research. So it can work, for example, for acceleration, displacement, electric or magnetic fields, gravitational fields, anything that is with acceleration, deceleration, and the movement of objects can use, projection of vectors. So basically vector projection, or can use the concept of projection. So there are plenty of ways of use it, but it's mostly used in physics. So when we are talking about, if you want to understand this concept a bit more easily, it's pretty simple. So here you can see a graph. So basically you're gonna have two vectors. So let's say this is the vector V and this is the vector Y. So basically what we can see here is that we'll have a sun, and this would be the shadow of the vector Y. Of the vector V, sorry. So basically this is simply the shadow of the vector V, and it's gonna go all over the vector Y. So if this vector right here is smaller, it's gonna go only partly on the vector Y, and if it's really large, it's gonna go completely over the vector Y. So basically the concept of projection is simply one vector going over the other one. So as I said, it's something that is pretty simple. Now, how can we determine what will be the distance of this vector right here? So basically of the projected vector right here. So basically, as you can see, the blue line, in this case, it's the green line or the blue line. The projection of this vector, how exactly we can see what its length. So the way we'll find it is pretty simple. We have this formula right here. So before we start, just to understand that the first part of the formula right here, so the division, will be scalars. In other words, this is just one number. So basically what we'll do, we'll calculate the distance of the vector V. We'll multiply it by the vector Y, divided by the vector Y, multiplied by the vector Y. So basically here we'll have Y at the power 2, and here we'll have V multiplied by Y. And we'll simply divide we'll divide this part of the formula by this part of the formula. Right here, Y will be a vector, so basically it's not a scalar. So what we'll do, we'll multiply this part of the operation, which is a scalar, by a vector. And what it's gonna give us, it's gonna give us a vector length. and that basically we will know exactly what will be the length of our new vector. So this is the main goal of this operation. So at the end, we are able to know exactly what will be the length of the vector that is projected inside of our, inside of this formula. So I hope now you guys have an understanding of what exactly is a projection. Another way, for example, that we can use, for example, projection will be simple. Let's say, for example, we have a mountain. So this would be a mountain, and here we'll have something on this mountain. So basically, let's say, for example, that, I don't know, we have the force, so the gravitational force that will push our object from the mountain, and we need to apply a certain force. So basically, we can use projection to be able to understand what force we need to apply to be able to lift this object. Yes, it's going to be a bit more complicated because we need to take in consideration the mass of the object, the speed that the object goes, and some other factors. Basically, so in basics, to understand how we can move this object, we need to understand projections. So basically, projections can be really useful in those cases. So I hope you guys right now understand what exactly is projection. You won't be a professional, well, you won't be a professional in projections, and be able to, you will be at least able to understand what is projection as an introduction to it. So that's it for this class, guys, and see you all in our next class.